for everyone who choose to attend this webinar. So my name is Meng Wu, and I am a committee member of the BCS Open Source Specialist Group, and it gives me great honor to introduce the speaker of the webinar, Ian Watt. So Ian Watt, I have known him for I think since 2018,
I
and
think so, yeah.
Ian is a prominent advocate for open data and civic technology based in Aberdeen, Scotland. He co-founded Code the City, a charity which leverages technology and open data to address social issues. The organization is known for organizing hackathons, open data workshops, and annual Scottish Open Data conferences. Ian has also played a significant role in local and national efforts to promote open data, including contributing to the Scottish Government's open data strategy in 2015. Ian's career spans significant achievements in public sector technology, digital, and data management. He has led large-scale digital projects and participated in EU-funded projects and lead an open data program for all 7 of Scotland's cities. Beyond his work with Code City, Ian involved in running community-driven initiatives like the Aberdeen Data Meetup and the Aberdeen Python User Group. Additionally, he is an approved volunteer trainer to Wikimedia UK, focused on using Wikidata as a public repository for linked open data. He is an ambassador for OpenAOK and was recently admitted as a Burgess of Guild of the City and the Royal Borough of Aberdeen, one of the oldest civic institutions of Scotland. So hand over to Ian now.
Okay, thank you, Mong. So yes, as our host said, I'm Ian Watt. I won't go through my whole CV, but I'm looking forward to going through some things with you tonight. So just bear with me for a second and I will share my screen. That one. Okay, could you just confirm that you can see my slides? Is that okay? Can somebody just give me a yes or whatever? Yes, you can see. Okay, thank you, Marina. Great. Yeah, thank you. Okay, so moving swiftly on. Where am I here? Okay, so tonight I'm going to be speaking about open data and specifically the context of that of Wikidata. I'll take you through what open data is and isn't, and then we'll look at some of the underlying principles of Wikidata, which is essentially a graph database. We'll look at what Wikidata comprises of, we'll look at some example data, and then we'll get into querying Wikidata with SPARQL, which is the query language, and then I've got some extra resources. What I plan to do is to share these slides with Mong, who I'm sure will send you links to download them or whatever, so you can access all of the information at the end. If you've got any questions, please feel free to pop them in the chat and I'll try to address them as I go, or just pop your microphone in and ask away. So let's get started. So first question is, what is open data? So open data is defined as data which is publicly accessible, that's been made available quite often from government, but not exclusively, which allows anyone to access, use, share it without restrictions or limitations. Good open data has an open license, so that the terms of the license clearly says what you can and can't do with it. So there's no hindrance or uncertainty. It comes without cost, so you should be able to use that data without any barrier of cost, making it free to use. And it should be in a machine readable format. So typically that can be a CSV or JSON or XML, which then makes it easily not only humanly readable, but easy to integrate into other software applications. Just checking that there's nothing in the chat there. 2 seconds. That's okay, thank you. So the benefits of good open data is that it encourages innovation. So if people can use that data, then they can do things with it, make new products, services, apps, websites, or whatever. it benefits governments if they're doing it by increasing transparency and accountability. And some of you may have come across performance data or spending data, particularly in England and Wales. Unfortunately, we have more of a problem with that in Scotland. But certainly since 2010, David Cameron and Nick Clegg's government, there was a push to make all government spending over £500 value available as open data, which continues to this day, as far as I know. It stimulates collaboration and research. So depending on the type of data, scientific data, whatever, people can then build on that and feed it into their other fields like healthcare or education, environmental science. And the reuse of open data has proven economic, social, and environmental benefits to society. And the European Open Data Portal has done some very good work on that, which is available to have a look at. And looking at the European figures, if open data in Scotland were done to the best standard, then we could have a benefit of around £2.2 billion per annum in Scotland's economy, which sadly isn't quite the case at the moment. So if we move on to the next slide. Here we are. So some of you may well be familiar with graph databases or relational databases. And I would imagine most know something about relational databases in this call. So relational databases generally have data organized in tables that follows some sorts of schema. The tables are often linked together and the data is normalized in those tables. And there's a use of primary keys allowing you to join data between tables. And the query language is primarily SQL. Now, in a graph database, which the Wikidata is, those things are slightly different. So items tend to be in the form of nodes, and these relationships between those are called edges. The databases are primarily schema-less, which means you can be very ad hoc in terms of how you grow and develop the database, although it's still advisable to have some sort of structure to that, obviously. And each of the nodes, i.e. the things and the relationships, the edges, can have properties attached to them. As I said, we can make those ad hoc additions relatively easily. And we use languages such as SPARQL in the case of Wikidata, or Cypher if you're using a product such as Neo4j, which is another popular product for managing a graph database. So that concept of the node and the edge, the thing and its relationship, is expressed in an RDF triple, which I think is a resource descriptor framework, if I remember rightly. Somebody will probably correct me on that. It's one of these things, you use the acronym so often you forget actually the underlying name. But the concept is that you have something which is a subject, you have something which is an object, and then you've got the predicate, which is the relationship between them. And one example would be Robert Gordon University, which is one of the local universities in Aberdeen. You could say that Robert Gordon University is an instance of university, but you could also say that RGU is located at. So you can have two statements about the subject, one of which is it's what it is an instance of, another one which is where it is located. And a good way to look at this is to use an example which I partially borrowed from a friend of mine who's a bit of an expert. So I'm just looking at the chat with somebody said, can the edges be bidirectional? Yes, and we'll see an example of that in a second, where you can have edges, and you can have things which are monodirectional but have reciprocal links between them, which tends to be the way that it's enforced in the case of Wikidata. In other concepts, which I think Neo4j is, I can't remember, I don't use it very often these days, they can actually be bi-directional, but it's a very good question. I'm going to leave this open so I can see it popping up here. So let's have a look at, here we go. So meet the family. And so here we have 3 people, Rita, Sue, and Bob, and Fritz. So we can say that Bob, so this is the kind of subject, predicate, object. You can say that Bob is, or in the Wikidata terms, is an instance of human. Sue is also an instance of human, as is Rita. Now, we can say that Bob is the spouse of Sue, and taking up Marina's point, we can say that Sue is also the spouse of Bob. If we were expressing that in Wikidata and modeling this, we would have 2 reciprocal one-way relationships there. So we can say Bob has a child, Rita, and we could also say Rita has a parent, Bob. Similarly with Sue. Now we can say that Fritz is a cat, or an instance of cat. So Fritz is something different from the human family. But we can say that Rita has a pet and Sue has a pet. Initially, I had my family's names on this slide with me, my wife, my daughter, and our cat. And so the cat is only related to the 2 women in this family because the cat didn't have much of a relationship with me, and therefore I didn't claim it as a pet. We could also add to, sorry, I would just say you can put in things like Bob has gender and so on. And you can add actual attributes to the people or the nodes in this case. So you can say that, you know, Sue has got brown eyes, has got a certain date of birth. You can say that Fritz has got ginger fur and is a weight of 5 kilos or whatever. And you could also have the spouse, or Bob being the spouse of Sue, you could have a start date and so on as well. So you can add attributes to both the nodes and the edges as well. So Wikidata is a very large public repository of open data, and I'll come back to the licensing question on it in a second. But you can see here, this is up until January this year, and you can see the climb in the number of items. Now, these are articles or pages about things, which can have many, many, many relationships to other things, and we'll see that in some of the examples we look at. So as of end of January, there were 115 million items in Wikidata. And if we were to look at an updated version of this, so this is actually from October 2024, I think it is. No, sorry, it only goes to 2020. You can see that there were 11.6 billion relationships between items. So these are the data triples, those RDF triples. That's actually dropped quite a bit because the way that Wikidata has been reconfigured of late. So it's still in the, I think it's still well in the billions, but it's slightly different because a number of items have been extracted from the core Wikidata and put into a different repository, which we can query in parallel with it, but it's slightly changed. And I wasn't able to get exactly the right figure for that, so I'd choose my old slide for this. So Wikipedia is one, or sorry, Wikidata is one of a number of platforms that the Wikimedia Corporation look after. And 2 or 3 you might be familiar with are Wikipedia, Wikicommons, and Wikidata. And these things all interrelate quite closely. So Wikipedia, which you're probably familiar with, contains information about things. It's licensed under a Creative Commons BY, which means attribution and share alike license. It's actually up to license 4 now. I think it's the standard one. So if you go onto Wikipedia and make a change, you are granting a CC by SA4, which means that anybody can reuse it. They must attribute where it comes from, and they must share it on the same basis. So while you can take data out of Wikipedia, you need to actually reuse it in the same licensing terms. Interestingly, if you've been following the development of large language models, then Wikipedia rather is held to be a major component of that. And the licensing of that information and how it's been harvested and reused is a very interesting debate topic for another time. Wikicommons is a source for media, so that's images, videos, and sound primarily. And again, it has got a range of licensing depending on the author of the work and how they license it. But it must be an open license. All of these work on an open license. So Wikicommons can have the CC by SA again, which is this kind of share alike attribution license. But it can also be the attribution license, CC BY, or it can be a CC0, which is a completely open, essentially public domain license where someone's given it that and said, you can do what you like with it. Similarly, Wikidata is completely a CC0 license. So it is completely open for you to take the data and use it as you will. There's no need to say where you got it from. There's no need to share under the same license terms. It makes it very open and very usable in lots of different ways. I don't cover later in the slides, but you can, I'll maybe touch on it slightly, but there are ways to get data out of Wikidata using API and programmatic approaches, which means that you can then integrate it into your own applications and so on. So let's look at some example data in Wikipedia. And the most common item that is generally used to illustrate this is Douglas Adams. So you can see that the Q42 for fans of Hitchhiker's Guide to the Galaxy might get the 42 reference. The only other similar Easter egg type thing that I know of is 2001. Can anybody guess, put in the chat, whose biographical article in Wikidata might be Q 2001? I'll give you a second to put something in chat while I have a drink of water. This is just a test to see if people are still online, really. No, almost. It's actually Stanley Kubrick's one. So there you are. Right. So let's look at an example of an item in Wikidata. So Douglas Adams. So you can see here, it's actually very difficult to make out in this black background here, but there is a label at the top. You can see. Sorry, let me go back. So Douglas Adams is a label. Under that, you've got description, English writer and humorist. You've then got other languages, and you can have numerous ones of them. And you've got at the top left, right here, you've got the identifier, the Q42, for instance. And then you've got statements. So statements are those triples, essentially. So the first statement here we're seeing is educated at. And then it's got a range of different values, because obviously people are educated in numerous different establishments. So the first one's St. John's College, and then we've got Brentwood School at the bottom. So these are called statement groups, and then you can have them ranked if you need to. So sometimes you'll have slightly different competing statements, or statements are no longer applicable but were true at one time, and you can have a preferred one, which is the current one, for instance. But in this one, you can see that's St. John's College, and then there's the qualifiers. He was there from 1971 to 1974. His academic major was English literature. His academic degree was Bachelor of Arts. And then you've got some references for that. And then further down, you've got Brentwood School. He was there from 1959 to 1970. And you can have whether there are references there and so on. So that's an example. Now, I could break out of this. Let's try this. I might have to stop sharing and reshare for a second. If you just bear with me for a second. Can you see that browser on your screen, on my screen share, or is it still showing the slides? You can see it, it's great. So this is the live Wikidata view. So if we look at the URL, the URI is wikidata.org/wiki/ then Q42. So that's that's a never, it's a kind of permanent and never changing URI, which always points to this item. So we can rely on it. And you can see here with the things I was showing you, you've got the title and so on. And then you've got various things here. So you've got an image, and you've got your signature and so on. I'm just going to scroll down it slowly, because this is quite an, extraordinary large entry. You've got mother, father, siblings, spouses, children, and so on. So as you can see, it's very substantial. And bear in mind that every aspect of this is programmatically queryable, because it is a database we're actually seeing a view onto, which makes it a very rich source of data for us. So I'm just going to move that back off here, and I'm going to go back onto my slide sorter. So if we've got lots of data in there, and anybody can contribute to it, we need to be able to get data out. And I'm going to show you how to do queries in a moment. When I say anybody can add to Wikidata, it's a bit like Wikipedia. It sounds a bit free for all, but actually it's very, very well policed. There are lots of bots and other guardrails in the background that are protecting the integrity and the quality of the data that's in there. And it's a continually improving source of data. So if we look at Wikidata, so there is a query service at https query.wikidata.org. And when we look at that, we can see this view here. And if I pick out some highlights, so you've got three things I would show you here. So there's an examples tab at the top. And that's actually really useful, because sometimes if you're looking for how to do something, then the examples give you some guidelines that you can start with and then adapt. We might look at some of that given time this evening. Then you've got this panel, input a SPARQL query or choose a query example. So if you go into this main bit, you can actually write some code to do stuff. And then you've got a big blue and white button down in the left, and these are the primary controls. If you click on this button, any code you've written will be executed, and you will hopefully, not always, as we'll see, but you'll hopefully get some results back, which will then help you to get the data out. So don't worry about the syntax here, but this is just an example of a query. So we've got some with a I forget the symbol name, but the hash mark there. So that's a comment that's just telling us what it's going to be doing. We've got a select statement, then we've got some clauses to actually interact things. And then we've got these P's and Q's. So the P's are the properties and the Q's are the objects. And you quite quickly get used to using them, but you don't need to know them, because there are shortcuts which mean you can type in what you're looking for and it'll convert it into P's or Q's quite quickly, as I'll show you in some of the examples. And as I say, if we then ran that, we would get some results back, hopefully. So this is an example of a simple query executed. And I've got three red panels here, one of which is on the left down the side. The other one is this where it says map here, just where my cursor is on the left, middle. And then we've got on the right a series of four different things. So let's go through them and see what they say. So on the left side, you've got things like this useful little link here, so a chain link, and that will produce a shortened URL for your query. So if you're running a query and you want to send a link to it to somebody else, then that will give you a very short, I think it's up to 5 characters now, link, which you can send to somebody else and sends them the query. Now, that's fine if you want to send a query that somebody knows how to execute and retrieves results. If I was to send it to my mum, it wouldn't be very much use as an 85-year-old woman. But there are ways to send it, and I'll show you in a second. It's a little slightly more useful. In the middle, where I think you saw a map on the previous screen, this is the results and what you can do. So depending on the type of data that you've got back in your query, and you can write it to get different things back, you can choose to display it as a table, which is the standard format by default. You've got an image grid. So if you've chosen to pull images of something back, then you can choose the image grid. You can have maps and line charts, bar charts, and so on. You may be able to do a timeline if you've pulled back a series of dates, things, and so on. So these are quite useful, and they're built into the querying system, which means that if you need some of these things as output, you can write a query and then quickly convert it into that graphical type thing you're looking for. And then on the right-hand side of the previous page, we have how many results you got back and how long it took to execute, which is a nice thing to see, but it doesn't really give us much. You've got a view of the code behind it you've written. You then got a download, and if you were to click this, you would see that it gives you options for CSV and, if appropriate, JSON and so on. And then you've got a series of different links you can have, and one of which is to the query that we saw in the left-hand one, but also you can send a link to the results. So you can, what you can do is you can write your query and say, give it me it as a map, for instance, and then you can send a link to that query, which means that my elderly mother would get a link to the map view of the results, not the query in SPARQL, which I think is much more useful. Okay, so now we're going to write some queries, and I will break out of this screen share for a second. Just bear with me. Okay, and I'm just getting browser back across. Just bear with me. And that over there. Some other view here. Okay, so let's go share it again and zoom. Okay, so you should now see the query service. I don't know if you're all following along on a PC, and if you want to, but what I'm going to do is do a series of different queries in here. If you go to query.wikidata.org, you can try running these for yourself. And each of the examples, I've actually created a little hyperlink shortcode here. So if you were to type that into your browser, you should get the same queries I'm running at the time if you want to try it as well. So what I'm going to start by doing is looking at the British Computer Society and pulling back data about people who are a member of the society. So if we look at this one, so I'm saying here, members of the BCS, and if you wanted members of the RSA, the Royal Society of Arts, Manufacturing, and so on, you could change the code for the thing here. But let's start with this. So I'm selecting something and I'm creating essentially a column called person, and it's saying where. So these are the parameters of the query. So I'm saying that the thing I'm going to assign the person to is, so you can see there I'm hovering over P31. That's an instance of human, Q5. In the context of the query we're writing, that's not strictly necessary unless the BCS admit non-humans as members, in which case you could have a problem. But as you can see, and then I'm saying the person should have the property, and if it should be highlighting here, a member of, and then an organization, and in this case, BCS. I don't know why it's not highlighting there. Yeah, here we go. Okay, so as I said before, we then execute the query, and as you can see, we've been given 14 results in 204 milliseconds. Can you all see that I've got a little list here of Q numbers? Yeah. Yeah. Just checking. You can see the results of that query, Mong, yeah? Yeah, that's fine. Okay, thanks, Marina. So getting that back isn't particularly useful because unless you memorize the QID codes of all these 14 people. So what we can do is we can change our query, and I'll just put this version 2 up here. So what I'm now saying is I want the person, but I also want what I've called person label, right? And so what I've said, so if it sees a variable called person, and then you stick capital L label after the same variable, it uses a lookup service to go off and find out what the label is. So it's a kind of third part, it's part of it, but it's a kind of, a different service which will go off and pull that information back. So if we execute this one, okay, so we've now got the same 14 results as we'd expect. And we've now got a series of names as well. Now we can click on this and sort them if we want. And we've got people like Charlene Hunter. Does anybody recognize some of these names, like Donald Knuth or Tom Gilb or whatever? I think there's some well-known names in amongst this list here. Okay, so so now we're starting to get somewhere. And if we were to just click on a link here, we could go and have a peek and see what it was. So if we click on that, yeah, there we go. So we've now found Charlene Hunter's thing, CEO of Coding Black Females. It's quite a short entry, this. She's human, female, programmer, software engineer, educated University of Birmingham, member of the BCS, and received an award at MBE. So you can see that there's a few bits of information that's quite interesting about her. But if we go back to the query, we can try and make this query a little bit richer by getting some more data about our subjects. So I'm going to put a third version of this in here. So now I'm saying person and the person label and the date of birth. And so you can see here person, and I've got this WDT, which is the property of date of birth. It should highlight when holding over it. Yeah, and then I'm assigning that to this DOB column. So so let's execute that. So now we've got people and we've got their date of birth, but our number of results has gone from 14 to 12. Can anybody guess why that might be? And there's a clue in Charlene Hunter's entry. So the reason why we're not getting back the full 14 is that people such as Charlene Hunter don't have a date of birth in their Wikipedia entry or Wikidata entry. And that's not that uncommon. Date of birth tends to be a little bit sensitive. So it's for living people, it's not always in there. But we've made it as part of our query, we've said that it's actually mandatory. We're asking for this and saying this must have that, it must be that, and it must have that. So we've essentially excluded those who don't have a date of birth. Now there is a way to get around that, which is to make it optional, which I'm going to show you in the next version. So let me paste in my updated code in here. So now I've said use optional for the date of birth bit here. And so by using optional, you can say, give me everybody's date of birth back who's got one. And if they haven't got one, I still want the record, but I don't, it doesn't matter so much. So now we run that and we can see that we've actually got two people lacking a date of birth, which is Charlene Hunter and Nicholas Ruddick. But we've got a bigger table. And if you remember when I was showing you around Wikipedia results, if we change our table now to a timeline, we can say generate a timeline of our BCS members who are in Wikidata. And so it plots them according to that date of birth. So as you can see here, the person's most recently born with a date of birth is Claudio Milhalia. I'm surely mispronouncing that. And the earliest one, I think, is Frederick Lever from 1915. Okay, so that's quite interesting, and it's probably getting more interesting the more we sort of add to this as well. So I'm going back to the table view. Now, if we go and do a little bit more, what have we got here? Okay, so I'm going to go to the next version of this. So now what I'm saying is I want the person, their label, their name, date of birth, and if there's a picture, if they have one as well. So let's run that and see what it says. And so you can see the table's now getting a bit more populated. So we've got their ID, we've got the person, we've got a date of birth if they've got one, and we've got a picture if they've got one. And so we can now change the view to an image grid, and that just gives us a grid of images of all the people who've got photographs here. And if you're looking for some sort of graphic for doing something, maybe a certain plants or something you want to illustrate or whatever, it can be quite useful to get an image grid that you can take a screen capture of. It can be quite useful. But of course, we can switch to our timeline again. But now we've got a timeline with enhanced with the images, which kind of just makes it a little bit nicer. And I'm just going to pause for a second because I'm running through this quite quickly. Has anybody got any questions at this point? No questions, okay. Okay, we'll press on and try the next version. So this is going to enhance it slightly again. So what I'm saying now is, so give me back all the same things we had before, but give us a place of birth. So you can see here, place of birth, P19, and we're going to assign that to a new variable or column name called place. And if we run that, you can see that because I've called place label up here to give me that enhanced service, again, it's retrieved by the query service, then you can see that they were born, so London, Milwaukee, South Africa, Pasadena, Dayton, and so on. Quite a good range of places there, which means that we can now have even more options. No, we'll come to that in a second. We can also add an order by clause. So if you wanted, we can do this at any stage, but we could do it just now. So if we put order by and then DOB, by default it will order by that date of birth coming back, so 1915 through to 2000. If we wanted to order it by place label, you can see that it then puts the blanks to start with, and then Dayton right down to Tongat at the bottom. So we can do ordering on all our queries, and we can, I don't have time to do it tonight, but we can do things like counts and group bys and so on, all the things you'd be quite used to doing in a standard SQL query. If we then do something with that place one, let's try this. So now I'm saying take the place and give it this is back as a set of coordinates. So it's taking the place and saying what are the coordinates of that place, and returning that. Okay, so I had some problems with this query yesterday when I was writing it, that it's very strict on some of the missing data. So I've reduced this, taken out some of the optional ones just now until I figure out why it wasn't working. but this is ones where it's actually got a place of birth and it's got coordinates for them. And if we then say, give this as back as a map view, it will, see, scroll down here. Oops. So you can see that we've got the place of birth, and if we click on, for instance, that place, although I haven't asked for the place name. Let me just change that so we can get should show place actually as well. Okay. Let's try this one here. It's not showing what the place is it? Sorry, I'm just slightly confused by why it's not doing that. It doesn't matter, because it should show in amongst these things here what the actual place that we've got is as well. But it needs a little bit of refinement. We can probably guess that's London. I don't know what this one here is. Somewhere in the north. In fact, we can do it this way. It looks like. So George Mallon, let's have a look at his Wikidata entry and place of birth. And oh, sorry, it's finding Melrose. Sorry, I clicked on the thing. So it's showing the place, but not the place label on the query. That's what it was. So if I put in here place label, question mark for that, and run it again. Okay, and then if we show it in map view, okay, you can see it's showing as Melrose. So yes, good question, Stephen. So the place. Let's have a look at George Mallon. Is it? In fact, look at London, right? So Wendy Hall. So I'm going to look at Wendy Hall. So you can see here, we've got her whole biography and so on. Place of birth, London. So if we click on that London there, it's got Q84. So this is the London, UK. So it's a very specific London, not any of the other Londons. So let's see which, can't spell. Okay, so you can see here, we were looking at Q84 for London. If we click on this London here, it's Q92561. And that's the benefit of having unique identifiers for every object. So there could be 6 Ian Watts. In fact, there are several Ian Watts in Wikidata, of which I'm one of them. But I have my own QID, as does London, UK. And if you had, I don't know, 3 River Ds in the UK, each one would have their own specific geographies and their own QID and stuff. So it's very specific. And I suppose that people can occasionally make a mistake in actually adding the data, saying that Ian Watt was born in, and then putting the wrong Aberdeen, for instance, in there. But what I find is that as I go through working with Wikidata, I tend to spend a lot of time improving the quality of the data. So one thing is, if we were, just use as an example, but if we looked at Charlene Hunter and discovered that she had some element missing here, so for instance, a picture, can we source an open licensed picture for Charlene from some other source if it's not in Wiki Commons, and add it so that we're continually improving? So when I get a grid, let me go back to here, and let me go back to this version, I think. So you can see this one has got Joanna Moore. There's no picture, there's no place label. Nicholas Ruddock doesn't have a date of birth, and no place of birth either. If I've got the time, I quite often will go and look at filling in some of those gaps, because I think we're all enriching the data and improving it and so on. What I didn't show you is if we're looking at this, so you can see here, for instance, Charlene Hunter, and it says sex or gender. Let's look at occupation programmer, and then it says software engineer and one reference. If we click on that, we can see that somebody has gone and looked at this website, which says that she's a software engineer, and has added that as a reference to improve the quality of the data, because essentially nothing in Wikidata should have no references other than probably human, because human would tend to know if we're dealing with a human rather than something that's not human. So, but for instance, she's got a member of the BCS, but it doesn't, there's no reference to say she's a BCS member. Excuse me. I think we're just about done doing the sample queries. Let me try this final one. So let's go back to query builder and okay, so this one, instead of members of the BCS, I'm actually going to look at the title of fellow of the BCS. So it's slightly different syntax. So it's still a human, although again, we could have got rid of that. And the person is, so this is B166. Award received, and then Q code 5424551, fellow of the British Computer Society. And then I've got some optional ones. So let's run this and see what we get. Because remember, we had 14, I think, maximum in the members. And actually, for fellows, we've got 153. So it's interesting that there are, according to Wikidata, there are more people are a fellow of BCS than there are members. What you'll find is that most people who have got Wikidata entries, not all, but most have got a Wikipedia page. And the Wikipedia page, the notability criteria is higher. So therefore, it's more likely that somebody's a fellow would have a Wikipedia entry rather than somebody who's just a general member. That's a generalization. But I would have thought that most people who are fellows are also members. And so, because I think if you look in here, you'll find, I think Donald Knuth and some others are in as being both members, and here we are, members and fellows as well. So it's arguable that everybody who is in as a fellow should probably be in as a member as well. However, I'm not an expert in BCS, so I don't know that particular. So we could enhance this query. We could start adding other things into it. That's as far as I wanted to go with that kind of simple introduction to querying. Is there anything you'd like me to try and change this query into something else, to add fields or to add more data to it? Please just put it in the chat and I'll try and accommodate you just now. No suggestions? In that case, oh yeah, is it possible to demonstrate attributes of an edge? Yes, so let me see. I don't know the data I'm looking at here, but let's take somebody who is notable. Let's look at Dame Sue Black and see what her entry says. Okay, so statements here. So just find something. Yeah. So here we go. So we've got Dame Sue Black. We've got this employer, and it says University College London, London South Bank University, and Durham University. Now, Durham University has got, so that your employer and you who's employing you is your edge. That's your relationship, and you can see that the Durham University one has got a start time. So if these were not overlapping, you would expect them all to have a start time and some of them to have an end time, and some very good, but we go back to Douglas Adams would be a good one for that, I think. picked the wrong one. So yeah, so it's a good example there of picking the wrong one. I'll just go. I can't see my browser bar for the. Okay, here we go. So here we go. Spouse. So we've got married to Jane Belson, and we've got a start and an end time, and then we've the end time end cause is death of the subject. Now that obviously could be divorce or other things. So Gary, you've asked, is it possible to query parts of labels such as searching for surnames and things? Yes, I mean, you can do that. Let me see. Let's try this then. So, and so the person has, oops. How about that? My keyboard's not responding well at the moment. Sorry about that. So let's look up surname. So just, I was trying to use a keyboard shortcut to do that just now, but unfortunately it wasn't auto-completing for me. But we'll take it from here. So one of the ways you can do it is give a name, family. Oh, it's because it's family name. There isn't such thing as surname. So okay, so copy that. But let me try and do that just now. So. Apologies for that. I'm so used to using keyboard shortcuts, but it seems to have switched itself off for some reason. So we can say surname, and then if we say Adams, we'll use Adams as an example, copy the link to that for quickness, and then it's going to be WD and okay, let's just try that and see if it runs. That one there by accident. I've got to miss it. Sorry, because I was chopping that other query to pieces. Just abandon that for a second. So Gary, apologies for that. It was a bit of hand-handedness there. It's just not working. The short answer is yes, you can do that. You can search for people by surname. You can also then return things and then ask for matches within that. What I would recommend doing is having a look at the examples tab at the top here. And there are loads and loads of different examples, some of which will be similar, and they're broken down into different areas. I think there's a particularly good example. What I also do is that I keep a little page. So I'll just go there for just now and go here. So this is my, everybody's got their own personal page within Wikidata, and I just keep this page. So when I'm figuring out complicated queries, I keep a little note to myself of what I've been doing so that I can go back and rework them or adapt them and so on. So you can, my own user page, just keep my own sort of learning page for that. I'm just conscious of time. Let me go back to my presentation just so I can finish it off within your allocated time. Okay, so you can see my slides again there, yeah? Oh, Marina, thank you. When you say personal page, do you mean a private space? So let's look at this. So what I've set up is if you sign up for a Wikidata account, so you can go to Wikidata and then you can create an account. If you've got a Wikipedia account, you sign into that, you can go to Wikidata and it carries over. So all of the wiki platforms are linked together. And once you have that, then you've got your own personal space. It's not a private space, so I could share my space with you to show what I've done or whatever. It's much more of a just a kind of place where you can create your own bits of queries and things. But if we look at this, so I'll ask Mong to share these slides with everybody because it's got some hyperlinks to some useful tutorials. So there's a guide to the Wikidata query service, some SPARQL tutorials, how to build queries, a kind of longer tutorial. Lucas Werkmeister, who's kind of a bit of a genius on this thing, doing some Wikidata querying with SPARQL. If you're into Python programming, how to do that. And then some of my pet projects I've been involved with. Oh, thank you. So these are things that I have built, so timeline of Aberdeen University graduates. There are lots of commemorative plaques around Aberdeen, and what I did is capture them all in Wikidata, and then I've done some analysis on them, saying how many are about women, how many are about women scientists, producing a map with graphics you can navigate around and whatever. The provost, that's like, I don't know if those of you who are not in Scotland, provost a bit like the Lord Mayor, so lists of all of the Lord Provosts over history. And these are more tutorials that tell you how to do things. The shipwrecks one is where I imported all of the shipwrecks around Scotland into Wikidata using bulk import tools. So it's a little tutorial on how you can do that. So there are lots of ways to get data in bulk into Wikidata and resolve it and so on. Lots of things to get involved with. So I'm just going to click through. So what I would suggest is sign up for a Wikidata account. If you're in Aberdeen or want to join us online, we do lots of things with Wikidata and other tools. We've got a monthly data meetup for data science community in Aberdeen. We've got a monthly Python user group. We run hackathons monthly, and we run the Scottish Open Data Unconference annually. We've got a newsletter which people can subscribe to, and you can take down my email address and drop me an email if you want. But other than that, just to say thank you.